Hello everyone, welcome to the Engineering Geology and Hydrogeology course. Today, let's learn about igneous rocks among the three major rock types. Rocks are classified into three major categories: igneous rocks, sedimentary rocks, and metamorphic rocks. Among these, igneous rocks are formed when magma either erupts onto the Earth's surface or cools underground due to changes in temperature and pressure. So what is the difference between the rocks we discussed in this lesson, igneous rocks, and the minerals discussed in the previous lesson? First, minerals are simple substances or compounds with specific chemical compositions and physical properties, while rocks are aggregates of minerals. Igneous rock is one type of rock. So, how are igneous rocks formed? Igneous rocks are formed by two processes: intrusion and extrusion. Intrusion is the process where magma intrudes to a certain depth within the Earth's crust and slowly cools and solidifies, forming intrusive rocks. Extrusion is the process where magma erupts onto the Earth's surface, flows down slopes, and rapidly cools and solidifies, forming extrusive rocks. Based on these two rock-forming processes of magma, intrusion, and extrusion, we classify igneous rocks into two major categories: intrusive rocks and extrusive rocks. Among intrusive rocks, if the magma cools and solidifies deep underground, it is called plutonic rock. If it cools and solidifies at shallow depths underground, it is called hypabyssal rock. As shown in the figure on the right, the volcanic cone and lava flows are formed by magma erupting onto the surface. These are extrusive rocks. Dikes, sills, and laccoliths, being closer to the Earth's surface, are considered hypabyssal rocks. Conversely, batholiths and stocks, which are found deep underground, form plutonic rocks. Sometimes, when a dike is particularly thick and its sides are steep, it is also called dike wall. You can see the details in these two 3D diagrams, which are very clear. Plutonic rocks, like batholiths and stocks, are large in volume. At the very bottom, the maze of dikes, dike walls, and sills located above the batholiths and extending towards the surface constitutes hypabyssal rocks. Lava flows erupted onto the surface, along with volcanic craters and necks, are all extrusive rocks. Landscapes in China formed by extrusive rocks include the famous volcanic crater of Changbai Mountain in Jilin Province, the volcanic neck of Changou in Shandong Province, and the Laohaitian mountain lava flow in Heilongjiang Province. The formation of igneous rocks is often accompanied by volcanic eruptions. These two pictures show scenes from the recent volcanic eruption in Tonga. One is a scene on land, and the other is a scene at sea. The Tonga volcanic eruption, which occurred in an area of human activity, was, for the people living there, a natural disaster that humans could not prevent. However, in essence, it is simply the process of igneous rock formation. From this volcanic eruption, we gain a profound sense of how small humans are in the face of nature. Humanity cannot alter natural laws. Therefore, in our exploration of nature, we must follow its laws. Igneous rocks are formed from magma deep underground that either intrudes into the crust or is extruded onto the surface. So, what are the chemical and mineral compositions of igneous rocks? In the Earth's crust, oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, hydrogen, etc. These 9 elements account for 98.13% of the Earth's crust. Among them, oxygen and silicon comprise 75.13%, making up the majority. They are predominantly silica-containing silicates. Differences in silicon dioxide content result in different rock colors, chemical compositions, and other characteristics. Therefore, based on the silicon dioxide content, igneous rocks can be classified into 4 main categories: acidic rocks, intermediate rocks, basic rocks, and ultra-basic rocks. When the silicon dioxide content is 65%, 75%, it is an acidic rock. When the silicon dioxide content is 55%, 65%, it is an intermediate rock. When the silicon dioxide content is 45%, 55%, it is a basic rock. When the silicon dioxide content is less than 50%, it is an ultra-basic rock. The mineral composition in igneous rock is divided into light-colored minerals and dark-colored minerals. Light-colored minerals contain silicon and aluminum components, such as quartz, orthoclase, plagioclase, and muscovite mica. Quartz is a representative mineral. Dark-colored minerals contain iron and magnesium components, such as amphibole, pyroxene, biotite, and olivine. Amphibole is a representative mineral. In igneous rocks, the combination of light and dark minerals determines the rock's color. The percentage of dark-colored minerals in a rock is often referred to as its color index. Based on the color index percentage, rocks are divided into 4 categories: leucocratic, mesocratic, melanocratic, and hypermelanic rocks. The specific classification is shown in the figure. When the color index is between 0% and 30%, it is a leucocratic rock. When the color index is between 30% and 60%, it is a mesocratic rock. When the color index is between 60% and 90%, it is a melanocratic rock. When the color index is between 90% and 100%, it is a hypermelanic rock. The color and mineral composition of igneous rocks follow a pattern of perigenetic association. For example, acidic rocks have a high silicon dioxide content and are leucocratic rocks. Minerals typically include quartz and orthoclase in association, with small amounts of biotite and amphibole. Intermediate rocks have a moderate silicon dioxide content. It is a mesocratic rock with very little quartz content. They are characterized by the association of feldspars with dark-colored amphibole minerals. Basic rocks have a lower silicon dioxide content. It is a melanocratic rock. They have no or very little orthoclase and quartz and are characterized by the association of basic plagioclase with dark-colored mineral pyroxene. Ultrabasic rocks have a very low silicon dioxide content. It is a hypermelanic rock. They have absolutely no quartz and are characterized by the association of olivine with pyroxene. In this lesson, we mainly learned about the formation of igneous rocks, their chemical and mineral compositions. Next class, we will continue studying the texture and the structure of igneous rocks and common types of igneous rocks. See you in the next lesson.